It's something right here. Yet based on one of the recent studies, and it's something scientists now refer to as Capotaro, or maybe Capotauro.
Today's video takes us deep into the mind-bending mysteries unveiled by the James Webb Space Telescope discoveries so strange they're rewriting what we thought we knew. Hidden in the data is a faint, almost invisible anomaly that researchers are calling Capotaro, though even its name is up for debate. This tiny smudge of light has scientists scratching their heads. It doesn't behave like anything we've seen before, and James Webb has once again pushed the limits of observation to reveal something completely unexplained. Could Capotaro be evidence that forces us to rewrite the story of how the first stars and galaxies formed? Or is it an entirely different kind of object, something much closer, stranger, and unlike anything humanity has encountered? In this video, we'll break down what we know so far, explore the most compelling theories, and see why Capotaro could become one of the most exciting discoveries of our time.
A candidate at a redshift of 32, called Capotaro. Capotaro isn't just another early galaxy candidate. At a redshift of 32, the universe would have been less than about 100 million years old.
So what exactly is this mysterious object? Why does it stand out? And how did scientists even find it? At the moment, the leading theory is that this could be the most distant galaxy ever detected, but the researchers are being extremely cautious with that claim. Before we jump into the details, though, let's quickly break down a few key ideas so everything makes sense. One of the biggest concepts here is the cosmic dawn. For years, scientists believed, based on theory and a few faint hints from older telescopes like Hubble, that the early universe experienced a slow, steady rise in stars and galaxies. This process was thought to stretch over hundreds of millions of years, starting only a few 100 million years after the Big Bang. NASA's own visuals show this timeline beautifully. In that framework, the first stars were expected to ignite about 200 million years after the Big Bang, with the first galaxies taking shape roughly 400 million years later. But when the James Webb Space Telescope turned its powerful eyes to the same regions, it revealed a completely different picture. The early universe wasn't calm at all. It was a turbulent, fast-paced era where galaxies seemed to form far sooner and far more rapidly than anyone had predicted. Up until recently, Hubble's observations seemed to line up neatly with what scientists expected. Its vision, however, only reached a redshift of about 11 roughly 500 million years after the Big Bang. That was the limit. But then came the James Webb Space Telescope, built specifically to peer into the infrared. It smashed through those boundaries and began spotting objects at distances no one had imagined possible.
Redshift 12 object.
That's Redshift. Object 12 was discovered as a candidate using JWST. Here are a whole bunch of objects that could be Redshift 12.
By May 2025, just months ago, Webb had already set a new benchmark. It confirmed the most distant galaxy ever observed, a cosmic powerhouse named MOMZ 14. This galaxy, which you can dive deeper into via the link in the description, existed a mere 280 million years after the Big Bang. It's a brilliant, tightly packed system that's churning out stars at a staggering rate in an environment almost completely free of dust. For scale, MOMZ 14 carries as much mass as the Small Magellanic Cloud, one of the Milky Way's own satellite galaxies. That makes it both luminous and surprisingly large for its age, a genuine cosmic heavyweight. And even with all our models, astrophysicists are still scratching their heads at how such an enormous, star-filled galaxy could assemble so quickly in the infant universe.
What exactly is MOM? Well, here this stands for Mirage or Miracle. This was the name of the initial survey that was designed to try to discover various luminous galaxies and find out if they're actually really far away or were just producing some kind of an unusual effect, making them appear too bright.
In theory, the gas filling the early universe should have been far too hot for stars to collapse and form quickly. That's why what James Webb is seeing now is so jaw-dropping. Using a cutting-edge technique called near-infrared dropouts, astronomers have spotted something even stranger than before, an object so distant and so unusual it defies expectations. To get what's happening here, you need to know a little about how Webb sees the cosmos.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
Instead of looking at just one color of light, the telescope splits its vision into multiple filters, each one tuned to a very specific wavelength. Think of it as switching through different night vision modes, each revealing a new hidden layer of the universe. These filters are crucial. By scanning across several wavelengths, Webb can pierce through the cosmic dust that hides galaxies in visible light and pick up the faint fingerprints of key elements. One of the most important is hydrogen, whose emission lines get stretched or redshifted as the universe expands. By measuring how bright an object appears through each filter and where it disappears, astronomers can estimate its distance. If astronomers come across a galaxy that's practically invisible in almost every filter but still flickers faintly in the longest wavelengths, that's a huge clue. It could mean they've just stumbled upon one of the most distant galaxies ever detected. For comparison, a typical galaxy at an average distance might only disappear in one filter, but still glow clearly in several others. But this new object, it's nothing like that. It vanishes completely in nearly every filter and only barely shows up in 2 of them. This is exactly what scientists call a near-infrared dropout, an object that only appears in the deepest wavelengths of light and nowhere else. The goal of the technique is to hunt for objects that suddenly drop out of visibility, signaling a dramatic break in their light spectrum. That's exactly how researchers found Capotaro, named after an Italian mountain. This incredibly faint source showed up only in the Shears survey and displayed an extreme dropout at 3.5 micrometers. When Giovanni Gandolfi and his team analyzed its light, they uncovered something jaw-dropping. The preliminary redshift for this seems to be 32. And yeah, let me repeat this again. A redshift of 32 isn't just higher than the previous record of 14.4, it's in a league of its own. In simple terms, this means we're looking at Capotaro as it existed when the universe was only about 90 million years old. Picture NASA's timeline of the cosmos. This would put it right in a region where scientists didn't even expect stars to exist yet. This pushes it roughly 200 million years earlier than the previous record holder, MOM Z14, taking us back to the dawn of cosmic time, an era when the first stars and black holes were just beginning to form. If this finding holds, Capotaro isn't just another record breaker, it's a direct window into the universe's earliest days, with profound implications for how galaxies form and evolve. Yet the mystery deepens. Capotaro is shockingly bright for such an ancient, distant object. Its ultraviolet glow matches that of some of today's most extreme sources, like the massive galaxy GNZ 11. This brightness suggests a mass of at least 1 billion suns. If true, it's a scenario our current models simply can't explain, because according to everything we know, a galaxy like this shouldn't exist just 90 million years after the Big Bang. For Capotaro to be real at redshift 32, it would need to form stars at a mind-blowing 100% efficiency, something no current model of galaxy formation can even begin to justify. But before we rewrite cosmic history or throw out the Big Bang, it's important to remember this is still an early candidate. The James Webb has already shown us how easily the universe can play tricks. Objects that look impossibly far away at first often turn out, after detailed spectroscopic analysis, to be much closer sometimes, even within our own cosmic neighborhood. By breaking apart their light into elemental signatures, scientists can pin down exact redshifts, and in many cases, these record breakers collapse back into far less dramatic distances. There's also the problem of contaminants and interlopers. A galaxy heavily shrouded in dust can mimic the same sharp drop in light that makes astronomers think they're seeing something at the edge of the observable universe. In reality, it could just be a dusty, lower redshift galaxy with missing light in certain filters. And yet, Capotaro still stands out. Its extreme break strength is very difficult for dust alone to reproduce. This leaves the door open to something far stranger, perhaps a compact, active galactic nucleus, or even a tiny, gas-swaddled black hole, the kind of mysterious little red dots scientists are only now beginning to catalogue.